We'll now continue discussing the law of sines. Just as a review, remember that the law of sines says that the sine of angle A divided by A is equal to the sine of angle B divided by B, which is equal to the sine of angle C divided by C. We're going to look at a set of problems in this presentation that illustrate a point about the law of sines, in that the solution for a problem can possibly have one triangle, two triangles, or no triangles that satisfy the given criteria. So we're going to begin with this example, which asks us to construct a triangle, if possible, for which angle A is pi over 6, or 30 degrees, side B is 12 centimeters, and side A is 7 centimeters. So we're going to begin by setting up a law of sines proportion for the information that we're given. Note that we are given both angle A and side A. So we definitely would want to use the fraction involving the A's. So I'm going to start there, and I'm going to start with sine of A, which will be sine of pi over 6, divided by side A, which is 7. In terms of the second fraction that we're going to use, since we're given side B is 12, we're going to use that expression. So we'll set this equal to sine angle B over side B, which is 12. Now we're going to cross multiply, just as we have in all of our other examples. So we'll begin by doing 7 times sine B, and then we're going to do 12 times sine of pi over 6. Now at this point, we want to note that sine pi over 6 is a value that we either have memorized or we have a chart to reference for. We know that sine pi over 6 is equal to 1/2. And so what we may want to do is to go ahead here, and instead of writing sine pi over 6, we may want to go ahead and say that that's equal to 1/2. And then furthermore, when we have 12 times 1/2, half of 12 is 6. So why don't we go ahead and simplify that as well, and make this side 6. Now we want to solve for side, or for angle B, and so we're going to divide both sides of this expression by 7 so that we isolate the term that has the B in it. So we have sine of B is equal to 6 over 7. Now recall that if you're finding an angle, you want to use your inverse trig function. So we're going to use this as sine inverse of 6 over 7. And what my calculator gives me for that is going to be equivalent to my angle. So I'm going to go to my calculator, and I'm going to do inverse sine of 6 over 7. And I want to be sure that my calculator is set to radians as I do this, because my initial value is in radians. And so when I do that, I have a radian measurement of 1.0296, which I'm going to round to 1.03. Okay, so at this point, we have to make a decision about the number of solutions that we expect to have in the problem. Remember that a law of sines problem, if you are doing an inverse sine to find your angle, and that's going to be the key point, if you're doing that inverse sine to find an angle, it is possible that you might have two triangles that satisfy the given conditions, or one triangle, or no triangles. And this is called an ambiguous case because we don't really know as we start the problem how many answers we're going to have. So what I do know is that when I'm thinking about my quadrants and the sine function, I know that the sine function is positive in the first and second quadrants and negative in the third and the fourth. And I know that this 1.03 that we came up with right here is my first quadrant answer. All right, so 1.03 as an angle is, roughly maybe like right in here. Now, you're also going to have a potential solution in the second quadrant. And in order to find that second solution in the second quadrant, you're going to want to take your answer, the 1.03, and subtract it from pi. All right, so in doing that, we're going to say pi minus 1.03, and this is going to give me my second quadrant answer. So I'm going to, on my calculator, subtract that answer from pi, and that's going to give me 2.11. And so that is another possibility for angle B. Now, we don't need to worry about the third and the fourth quadrants because we know that the 6/7 that we were working with was positive. And so since our value is 6/7 and it's positive, we only really need to worry about the first and the second quadrant. We're not going to have an answer coming out of the third and the fourth because that's where sign is negative. Okay, so now we need to figure out if both of these solutions are possible triangles or if we can eliminate one of our solutions. And so in order to decide that, we're going to look at them one by one in terms of the triangle. All right, so I'm going to draw a triangle. I'm going to label what I know. So I know that angle B in the first case is 1.03. I know that angle A is pi over 6. So I'm going to do that in my calculator. Pi divided by 6, and I get 0.52. So I'm going to just jot that down as a decimal so we can work with it a little bit. All right, but all I'm doing there is saying that A is pi over 6 and putting it in my calculator. Okay, so now the question is there room in this triangle to do an angle C? So if we were working in degrees, we would want to check to make sure that the three angles that we're going to come up with are going to equal 180. If two of the angles were already over 180, then there wouldn't be room for angle C, and we would eliminate that as a potential solution. Since we're working in radians, we want to be sure that the three angles add up to pi, because remember that pi is the same thing as 180 degrees. So I'm going to take pi, which is the total angle measurement for all three angles added together. I'm going to subtract the 0.52. I'm going to subtract the 1.03. And that should leave me with angle C, assuming that there is room for another angle. And so that gives me 1.59. And so now I know that angle C, that there is room for that angle, and furthermore, it's equal to 1.59. Okay, we're going to do the same thing on the second one. So I'm going to draw another triangle. We're going to fill in what we know. This time angle B is 2.11. Angle A is still going to be 0.52. That's given to us in the initial problem. And we want to make sure that there's room for angle C. So we take pi, which is the total of all three angles added together. We subtract 0.52. We subtract 2.11. And we're going to see if there is room for a third angle. And so that gives me 0.51. And so it's a small angle, but it is there. And so angle C in that case would be 0.51. So this tells me that both of these solutions are viable. They both produce triangles that meet the original criteria. And so at this point, our problem sort of branches off into two possible solutions. Okay, so let's look and see what we also need to find. We have angle A and side A. so we're done there. We have angle B and side B, so we're good there. We have angle C, and we do not have side C. So in both cases, we're going to have to work to find side C. Okay, so let's set up our law of sines and find those two values and finish up this problem. All right, so we're going to come back over here. We're going to use our sine pi over 6 over 7 as one of our ratios. And now we're going to set it equal to a C fraction. So I'm going to say sine of 1.59 over side C. And we're going to cross multiply. So I'm going to have C times sine pi over 6 is equal to 7 times sine 1.59. We're going to divide both sides by sine pi over 6. Making it cancel on the left. And so angle C, or side C, is going to be, and I'm going to enter this in my calculator, sine 7 times sine 1.59 divided by sine pi over 6. And that gives me 13.997, which is going to round to 14 centimeters. So we now know that in that case, side C is 14 centimeters, and that completes the first triangle. We're going to do the same thing for triangle 2. So I'm still going to use my A ratio. I'm going to set it equal to my C ratio, which will be sine of 0.51 divided by C. We're going to cross multiply. So C times sine pi over 6 is equal to 7 times sine of 0.51. We're going to divide both sides by sine pi over 6. Causing it to cancel on the left. And we're going to enter in the result into our calculator. So 7 sine 0.51 divided by sine pi over 6. And that gives me 6.83, which we're going to round to 6.8. And that completes my second triangle. And so again, this problem produced two answers that satisfy the conditions of the original problem. Okay, so let's look at one more example. A very similar example, we're asked to construct a triangle if possible for which A equals 75 degrees, B equals 15, and A equals 10. And so we're going to begin with our law of sines. We have both angle A and side A, so we'll definitely use that. So we'll say sine of 75 degrees and divide it by side A, which is 10. Then we're going to set it equal to our B fraction. So sine angle B over side B, which is 15. We're going to cross multiply. So 15 times sine 75 is equal to 10 times sine B. We want to first get sine B by itself, so we're going to divide both sides by 10. And remember that if we're solving for an angle, we want to enter it into our calculator as an inverse problem. So we're going to enter it in sine inverse of 15 sine 75 degrees over 10. And that should give me angle B. So you want to change your calculator to degree mode. And then we want to enter that in. So inverse sine, we're going to do 15 sine 75 and divide that result by 10. If you do it correctly, your calculator should give you an error. And it gives you an error because this set of criteria given to us in the problem does not produce a triangle at all. And so if you're working a problem and you do your inverse sine and you get an error on your calculator, what that is telling you is that there is no possible triangle that meets the conditions given in the problem. And so there's really nothing else for us to do in this case except to say that this doesn't produce a triangle. And you can see that in this picture, that if you have an angle of 75 and one side that's 15, that your other side, which is 10, is not long enough to actually come down and meet the triangle at any point. And so it does not produce a triangle.